Hey, ninth graders. Well, you finished your sequences unit. Hopefully you found it to be fairly simple and very doable. So today we're going to go through, well, I'm going to do the practice test. You should have already done it. And now you can check and see how you did. Of course, online, you probably already know how you did, but if you missed any, you can see why. So pull your work out from your practice test and let's go over it and see if you made any mistakes, if you can find them. All right, let's see. All right, so you should have your unit practice test for sequences. I just pull this out of the binder. So let's take a look here. For each sequence given, determine if it is arithmetic or geometric. Okay, you'll write that here, geometric or arithmetic. And while you're doing that, of course, you're going to tell me D or R. Okay, the test will be just like this, as you know. So these are the things we'll be looking for. Then you're going to write the explicit function, recursive function, and you're going to find the term that's required. So, all right, so let's see, what type is this? So obviously not adding the same thing. Let's try 16 over 4 is 4. 64 over 16 is 4. Yep, it is geometric. And R is 4. Okay, the explicit we know is f of n equals first term 4 times r, which is 4 to the n minus 1. Okay, now, yes, they both have the same base. So this is 4 to the 1, and that's 4 to the n minus 1. So, and I haven't talked to Mrs. Johnson about this particular problem yet to ask or decide if we want it simplified. My guess is we're going to be okay here. But if you were to simplify it, because when the same base, remember you had exponents, and 1 and negative 1 is 0, and leave us 4 to the n. Or maybe we'll take either one of those answers. I don't know. We'll probably so. But I don't know if the one on the test will simplify like this anyway. Let's see. Let me look. I actually have the test.
Lucas Duran, please come to the front office. Lucas Duran, please come to the front office.
Nope. So won't be an issue on the test. Okay. Recursive, well, identify the first term, of course. First term is 4, and then your recursive function is f of n equals f of n minus 1 times r, and r is 4. Okay, do not forget to identify the first term. Now, f of 7, we're going to use the explicit to find f of 7. So we have f of 7 equals 4 times 4 to the 7 minus 1. I use this top one because that's what form you're probably going to have it in on your test. So f of 7 equals 4 times 4 to the 6. Now this I would expect you to simplify. Okay, this is 4 to the 1, and we know if they have the same base, we add exponents, so f of 7 is equal 4 to the 7. And then I do believe we might want you multiplying that out. We'll have to tell you that come test day, but 4 to the 7, if we use our magic box here, is equal to 16,384. Okay. And if that's required, you'll see that on the test. I should have asked Mrs. Johnson if we were going to want that. We haven't really talked about that either. Okay, my calculator won't turn off. And why is that? There we go. All right, number 2. Let's see. 15 minus 20, negative 5. 10 minus 15, negative 5. You can see what's happening. It is arithmetic. And D, the common difference, is negative 5. Okay. So explicit, f of n equals first term, 20, plus d, but d is negative, so I'll just go minus 5 times the quantity n minus 1. Now, of course, we don't leave it like that because we can remove parentheses with distributive property, which gives 20 minus 5n. And be careful with your negatives. Negative times a negative is a positive 5, and we can add like terms. So our answer here, f of n, is negative 5n plus 25. Okay, recursive. Don't forget the first term. F of 1 equals 20. And f of n equals f of n minus 1 minus 5. Now, if you put plus negative 5, that's all right, but there's no reason to do that. And the 40th term, well, of course, we'll go back to here. F of 40 equals negative 5 times 40 plus 25. Well, negative 5 times 40 is negative 200 plus 25. We get f of 40 equals negative 175. Okay. 3. What type is this? Looks to me like, well, let's find out. Negative 1 minus negative 5 is 4. 3 minus negative 1 is 4. And obviously, 7 minus 3 is 4. So it's arithmetic. Has a common difference, and D is 4. They're adding 4 every time. So our explicit, again, with arithmetic, f of n equals first term, negative 5, plus D, which is 4 times n minus 1. So we have negative 5 plus 4n minus 4, a little distributive property. So f of n equals 4n minus 9. There's your explicit equation. Recursive, don't forget the first term. F of 1 equals negative 5. And f of n equals f of n minus 1 plus 4. So what that says is go from term to term to term. You add 4 each time, and that's what we did. Okay. Don't forget the first term as part of your answer, though. Now, f of 95. So back to here. F of 95 equals 4 times 95 minus 9. Well, 4 times 95 is 380 minus 9. So f of 95 equals 370. 71. How are we doing? Hopefully well. Now, if you're not understanding anything, ask your teacher. Okay, number 4. Well, they're obviously not adding the same thing, so let's try the common ratio, 125 over 625. Okay, that is 1/5. 25 over 125 is 1/5, and of course, 5 over 25 is 1/5. So we have a common ratio, so it is geometric. And R is 1/5. They're multiplying by 1/5 every time, or what's that line in a fraction mean? The fraction bar means to divide. So in other words, they're dividing by 5 every time. But in geometric, we don't think in terms of that, do we? Because geometric, we think we have a common ratio, or in other words, a common factor. And so you can get yourself in trouble thinking about dividing, but okay. The explicit, okay, we have f of n equals first term, 625 times r, 1/5. And r, since it's a fraction, will be in parentheses to the n minus 1. And we'll leave it right there. Recursive. First term is 625. F of n then is f of n minus 1 times r, which is 1/5. Again, make sure you put the r in parentheses. We always put the fractions and negatives in the parentheses. Okay, now over here. 10th term, 625 times 1/5 to the 10 minus 1. So we have f of 10 equals 625 times 1/5 to the 9. Okay, well, if we factor this down, this is 5 times 125. This is 5 times 25, and this is 5 times 5. And so what you have here is what? 1, 2, 3, 4. 1, 2, 3, 4. That is 5 to the 4. Times, now if I take this inside, 1 to the 9th is 1 over 5 to the 9th. Okay? Then I move that over here. That gives me 5 to the 4th over 5 to the 9th, which is 1 over 5 to the 5th. And that would be my answer. 1 over 5 to the 5th. Now, we did this kind of thing in 8th grade. This is something you should be able to do, to simplify like this. All right, number 5. Given the first term and the recursive formula for a sequence, generate the first 5 terms. Okay, so the first term, that's where we're starting, 24. And what does it say? So our first term is 24. Multiply by 1/2. Well, half of 24 is 12. Half of 12 is 6. Half of 6, I believe, is 3. And then half of 3, that would be 3/2. Now, Mrs. Johnson probably doesn't care if you write 3/2 as 1.5. I'm not crazy about that, but since we try to do things the same, we'll probably take either answer. Unfortunately. Okay, number 6. Now, our first term is negative 16. And we're adding 10 every time. So negative 16 plus 10 is negative 6. Plus 10 is 4. Plus 10 is 14. And plus 10 is 24. Okay, how'd we do on that front page? Not that. Let's see, here we go. Page 2. So let's see what it says here. You have decided to breed rabbits. In your first year, you end up with 4 female bunnies. The next year, those 4 females give birth to 4 more baby girl bunnies. Suppose this pattern continues from year to year. So we have year 1, year 2, year 3, year 4, year 5, year 6, year 7. Year 1, you have 4 female bunnies. Now, each of those 4 give 4 female bunnies, so that would be 16. And each of those 4 female bunnies is 64. And each of those, then we can take our little magic box, see what's happening is it obviously is geometric. We're multiplying by 4 every time, so 64 times 4, 256 times 4, 1024. Then you can see I'm using the magic box here. Times 4 is 4096 times 4. My. Hope you have a big cage. 16,384 female bunnies in year 7. Unless, of course, you decided you were going to eat some of them and threw them on the Barbie. And then, of course, that'd be smaller. But we won't go there. Okay, so we filled in our table. Now let's answer questions about it. Write a recursive function to represent this situation. Well, recursive, so we have to identify the first term. The first is 4. We started at 4. And then, of course, f of n equals first is, no, it's recursive. So that's f of n minus 1 times 4. And it says write an explicit. Okay. So we know explicit. We did all that on the front side. F of n. Okay. Equals first term 4 times r, which is 4, because I should have identified it up here. We're multiplying times 4 every time. So 4 times r, which is 4 to the n minus 1. And yes, wow, we had that on the front, didn't we? That same equation. We did. Very number 1, we ended up with that same thing, but oh well. And we could probably leave it there, but if you simplified it, that's okay. 10. If this pattern continues, how many female bunnies will you have on the 10th year of breeding? So f of 10 equals 4 times 4 to the 10 minus 1, which is 4 times 4 to the 9. So f of 10 equals 4 to the 10 bunnies. I wonder if that number even fits in the calculator. 4 to the 10. Oh, it does. That's a lot. 1,048,576 bunnies. Like I said, hope you have a big pen, or you can have a barbecue for the whole town. It's nice. Okay, on the 15th year, four times 4 to the 15 minus 1, which is 4 times 4 to the 14. So the 15th year, you would have 4 to the 15 bunnies, which of course, if we multiply that out, 4 to the 15, my, that is 107,374,1824. Wow, over 1 billion bunnies. See, you should have started eating them a long time ago. The 20th year. So 4 times 4 to the 20 minus 1, 4 times 4 to the 19, which is 4 to the 20. Oh, bunnies. Well, 4 to the 20 is, see that? It's a scientific notation number. We're not going to go there because it's 1.099 times 10 to the 12th. We're going to move this decimal 12 places. I'm not going to write that. We'll leave it right there. 4 to the 20 bunnies. Okay. 13. You're trying to raise money to buy an iPhone. Your parents tell you that if you use $50 of your birthday money, $50 of your birthday, how much birthday money do you get? How do you get $50 for my birthday? Okay, so you're better off than I am. You're going to use only $50 of your birthday money. They will pay you $3 for every chore you complete. All right, well, let's do our table. 1, 2, 7. All right, if you do one chore, you get $3, right? But this says, notice, total money. You're using $50 of your birthday money, plus you did one chore, so now you have $53. You do another chore, you get 53 more. So obviously we're adding $3. So that makes it arithmetic, and D is 3. So that'd be 56. Then we do another chore, so it'd be $59. Another chore, $62. Another one, $65 and $68. And 7 chores, we have $71. Write a recursive for this situation. Well, recursive, so of course we start with the first term, which of course is 53. Just a second. Let me pause this for a second. Let's see here. Okay, that took care of. Sorry about that. Old students coming by. Okay, we're writing a recursive function to represent the money we're earning for our iPhone. So the first term, 53, okay, and then of course, a second. Now I've had students that had questions about this. They said, wait a minute, you started with $50, then when you did one chore, you did 53. Yes, that is our first term. The $50 would be term 0, okay? Because that's before you did any chores. So the first term really is 53. And then of course, our function is f of n. Now this is recursive, so f of n minus 1. And what do? We added 3 every time. So there's your recursive. Okay, for explicit, f of n equals first term, 53, plus d, which is 3 times n minus 1, which of course we would simplify to 53 plus 3n minus 3. So f of n equals 3n plus 50. Okay, now, see, if you remember your linear equations, the y equals mx plus b, see, f of n is just another name for y. Y equals mx plus b. See, remember your y-intercept, or b, is when x is 0. So what I just talked about up here, see, that's your 0 term. So that should make sense. Okay. 16. How much money will you have raised on your phone on the 20th completed chore? Well, here's our explicit. So we want f of 20 equals 3 times 20 plus 50. So 60 plus 50. So on the, after the 20th term, you would have $110. Still a long way from buying an iPhone these days, since they're ridiculous. Okay, on the 50th completed. So now we're looking for f of 50. So 3 times 50 plus 50. So 150 plus 50. After 50 chores, you would have $200. 100 chores, f of 100. 3 times 100 plus 50. 300 plus 50. So after 100 chores, you would have $350 towards your iPhone. Well, you're getting there, but you still have a ways to go, don't you? Okay, and this last one, which I don't know if we're putting a review question on the test or not. We haven't talked about it, but let's look at it just in case. Solve by graphing. See, we don't want you to forget how to do this. So this first equation, we graph it. I'm going to write it down over here so we can actually see what we're working at. 2x minus 7. So the y-intercept's at negative 7. 1, 2, 3, 4, 5, 6, 7. Slope says go up 2 and right 1. And somewhere I have a straight edge. This will do. Okay, the other one, the x minus y equals 2. It's not in slope-intercept form, so I'm going to do that. Minus x, negative y equals negative x. Remember, that's negative 1x. Plus 2, divide by negative 1, everything. We get y equals negative divided by a negative is a positive 1x minus 2. So the y-intercept is at negative 2 right here. Slope says go up 1, right 1. And play dot to dot. And you can see where they cross. Right there. At, what is that, 5, 3. Okay. And then it says solve algebraically. So over here we have y equals 2x minus 7 and x minus y equals 2. There's our system. It's set up to do by substitution. You might as well do it that way. Just be careful with this negative here, because when you substitute, you have x minus y equals 2. But we're substituting, see, the 2x, oops, 2x minus 7, we substituted in place of y. So now a little distributive property gives me x minus 2x plus 7 equals 2. Combine like terms, so negative 1x plus 7 equals 2 minus 7. Now I'm going to bring it up here. Negative 1x equals negative 5. And x equals 5. Then I'm going to put it in this top one here. Y equals 2 times 5 minus 7. 10 minus 7, y equals 3. So our answer, 5, 3. Now, you better get the same things as we did the same set of equations. But that's a good sign that we did both of them correctly. All right, now that's your practice test. Hopefully you did really well. If anything on there you did not understand, you could not find your mistake, then ask your teacher to help you. Okay, the test will be just like that. I think it's a test you can do very well on. Especially the first part. Be careful on these tables that you start at the right spot. You start at the right spot on problem 7 and problem 13, then you'll probably be just, do just fine. So, okay. Well, good luck on your test, and hopefully y'all get hundreds.